talking about triangle congruence criteria. So we had those 4 criteria, and we talked about why some of them worked and why some of them didn't work. And we were sort of looking through some situations and when can you use those criteria. Because typically, once again, it takes a lot of information to prove that 2 triangles are congruent. You have to prove all of those sides are congruent, all of those angles are congruent. That's a lot of stuff. So we were using those shortcuts to help us see, okay, if I just have 3 pieces of information, is this enough to show that my triangles are congruent? And that's sort of what we were walking through yesterday. So let's do just a quick refresher in this warm-up to remember what were those congruence criteria that we used yesterday. So looking at this first example, which of our 4 congruence criteria would allow us to prove that these 2 triangles are congruent? These first 2. So angle, side, angle. So good, that's right. We have an angle that matches, we have a side that matches, and then we have another angle that matches. Yes.
What's the difference between angle, side, angle, and equal side? Because they work the same.
So this one's going to be angle, angle, side. This one's angle, side, angle. The main difference, this side length, it doesn't fall in between those 2 angles. This side length falls in between those 2 angles. So even though you have the same pieces,
It's not fit together.
because of the order that it happens around the triangle, because that side length's outside of those 2 angles, and because this side length is inside those 2 angles, we have different criteria because it's 2 different situations technically, even though we have the same information. It does give us 2 different situations. And so angle, angle, side, or side, angle, angle, same thing, of course. But whether that side is in between those 2 angles or not changes the difference between them. Did that help explain that?
Yeah.
Yeah. And so we have angle, side, angle, and then we have 2 matching angles, and then 2 matching side, and so angle. Are we okay with these first 2? Scroll down. I'm going to move this stuff up a little bit. Right. So we have these 2 ones down here. This one on the left. What congruence criteria can we use for that one? Side, side, side. We have 3 pairs of matching sides. So that one's simple. That one's easy enough. And then what is that last one we have going on?
Side. Or is it side, side, angle?
It will be side, angle, side. Because that angle is included in between both of your sides, it's going to be side, angle, side. Remember, we can't use side, side, angle, because if we were to turn it around, that's a no-no in class.
So we're never going to use that one?
We would never use that one.
Now they're going to use that.
There is,
or angle, angle, angle.
there is one situation where technically it works. And we'll talk about that on Monday. But we give it a different name because it's a special situation. And so there's technically a situation where side-side angle does work, but it needs to have a special type of angle for it to work. It needs to be a right angle. And we'll talk about why specifically and what those sides need to be for it to work. But other than that, you would never use side-side angle or angle side-side. So in the way we can recognize whether it's one of these situations where it's not congruent or it's one of these situations where it is congruent is if that angle is in between those 2 sides, just how up here with side or angle side angle, that side length was in between our 2 angles. If that angle is in between our 2 sides, it's a side or angle side. Does that help explain that? Okay. So these were 4 congruence criteria. So we are going to use these congruence criteria to help us prove whether 2 triangles are congruent. We're going to be given some situations. We're going to do those 2-column proofs just like what we did with those parallel lines. We're going to fall back on that. We're going to start with some informal proofs and just look at the reasonings behind them, and then we'll slowly progress into those actual proofs. And that's going to be basically what we're going to practice all of next week is doing those proofs. So we'll have a lot of time to sort of nail those down. But before we get to actually practicing those proofs, we still have a couple things we want to refresh in our minds that might help us solve some of these situations. So just some of the things that we talked about earlier in the year that I think might help us with some of these triangles. So I have this situation. I have those 2 angles there. So what would be the value of x, and what do we call these types of angles?
65. And they're vertical.
So it's 65 degrees. It's because we have vertical angles. Good. So once again, I don't know why I'm writing vertical angles. So once again, it's vertical angles. Anytime you have an intersection and you have two angles on opposite sides, those are vertical angles. Or if you, in an example with triangles, these might be like your two triangles you might have. And so if you ever see a situation like that where those two triangles are sort of touching, you're typically going to have vertical angles. So that's something to always keep a lookout for. That'll help us solve things.
I was literally about to point that out. No one else saw that?
That was a strange situation. All right. Another thing that might show up is you might see parallel lines. So some things we need to remember with parallel lines are those parallel angle pairs. So what would be the degree measure of x, and what type of parallel angle pair do we have here?
Alternate here. Oh, guys, what am I thinking? I was so dumb.
So we have our parallel lines, our transversal that cuts across it. So 78 and 78 because they're congruent and they're alternating side of that transversal. Alternate interior angles is the most common type of parallel angle pairs I see with triangle congruence. I can't really remember other situations where I see like exterior angles or corresponding angles. Alternate interior angle is the one that comes up the most frequently that I've ever seen. And so these are two things that might help you find some missing angles. Because once again, we have to find those missing pieces. We have to find those pairs of congruent sides. We have to find those pairs of congruent angles. And so using these situations, these will be your reasonings behind why some of your angles are congruent. That can help us get those criteria. So now we can jump into that paper. And our triangles congruence proof. So we're going to start off doing some informal proofs. We're just going to sort of talk about the reasoning behind them, not really write it in that proof method, and then we'll jump to the two-column proof on the back side where we'll actually start working with those two-column proofs. But we'll do a slow transition where you only have to fill in some of the information rather than having to fill out the whole thing. Okay. So just like before, you're going to be given some information, you're going to be asked to prove something, and then we'll be given a picture, typically. So we were given that FB is congruent to FC, which is congruent to FR, which is congruent to FA. And then we're trying to prove that triangle BCF is congruent to triangle ARF. So something that I like to do is I like to draw on that picture to help me realize what my pairs are. So I like to highlight some information to help me visualize where my congruent states are. So I'm told that FB is congruent to FC, which is congruent to FR, which is congruent to FA. So all of those sides are the same length. That's what we're told to start off with. That's also our given information, so we can write that down for what's given. FB is congruent to FC, which is congruent to FR, which is also congruent to F. This means it's a line. That line above, like this means they're line segments. It's not, I'm not a super stickler on that. If you have two letters next to each other, it's going to be a line. So if you don't put those lines above it, I would not. On the test, they will most likely have drop-down tabs where they'll have information filled in where you have to choose, and they'll then have the lines for you. You won't have to like type that in or anything like that because you can't really put a line above with typing. So special features. All right, so we have two pairs to start off with. I'm told that this side, this edge is congruent to that side, this side is congruent to that side. So I have two congruent sides already. I have two pieces of my congruence criteria. But once again, we need 3 pairs in total to get these to work. So I need one more piece of information, at least, to help me figure out which congruence criteria I need.
I think I know.
What do you see?
They add up to 180 and they're 90 degrees.
What adds to 180 and what's 90 degrees?
BFR and CFA.
So BFR and CFA.
Guys, I really thought about it.
So we have some vertical angles. So you're on the right track.
but not really.
You were there. You were getting there. And so BFC, angle BFC, is congruent to angle, let's see, B matches with A, so AFC, or AFR, I'm sorry. So angle BFC matches with angle AFR, and the reasoning behind that would be because we have vertical angles. So good, we were able to catch those vertical angles. Now we have three pairs. We have a pair of sides, we have a pair of angles, and we have another pair of sides. So is that enough information to say that these two triangles are congruent? Now, which criteria should we use to say it so? Side angle, side. Once again, that angle falls in between your two sides, and so we have SAS. And you can then say that triangle BCF is congruent to triangle ARF.
Does it get much harder than this? Like, is this it?
This is like essentially what we'll be doing. We're going to put it in the two-column proof, so where you have your statements and your reasons column. But other than that, this is like the goal. Figuring out what you're given information, finding those three pieces of information to show, and then stating which triangle is there. So if you think that's easy, awesome, because then the rest of us should be pretty easy. So there might be some situations where it might be a little bit harder to find some pieces of information, but that's what we're going to be practicing all throughout next week to get that down. So just like the last one, we're told that line WH is parallel to line EL. So we're told that these two sides are parallel. And then we're told that AH is congruent to AL. So that's our given information. So WH is parallel to EL. And then AH is congruent to AL.
Will it help me to like extend my parallel lines?
It could. Might help you find something. And whenever you see parallel lines, those are always indicators that they're trying to get you to look for a parallel angle pair. So anytime you see parallel lines, you should have like a little knee-jerk reaction, or like a little radar going off in your head. Oh, I need to look for parallel angle pairs. Typically, alternate interior angles are your most common one you're going to see as well. It's good look at you gauge. So far, all we have is one set of congruent sides. Once again, we need three pieces of information to be able to prove things are congruent. So we only have one piece. So we need two other things. We need two other pairs of congruent pieces. What was that? We have another set of vertical angles. We have WAH and ELA, or EAL, I'm sorry, are vertical. So WAH is congruent to angle EAL by vertical angle. Vertical. Good. So that's one extra piece of information. So now we have two pairs. Once again, we need a third.
Little sides right there, like AH and LA, and like the little side lines.
AH and LA. Yeah, that was told to us in our given information. So that's one of our pairs we already know already. But good, good. We want to be able to recognize that.
So I think we're trying to find something like I'm just like throwing out there like alternate interior, like one of those things.
Probably, because based off that given information, we've only used one piece so far. We've only used the fact that we have congruent sides as one of our congruent pairs. They told us that our lines are parallel. Typically, when they give you given information, they're expecting you to use it somewhere. So they're expecting us to use the fact that those lines are parallel. So they're basically telling us there's a parallel angle pair out there. We just need to find it.
Okay. So to extend those parallel lines and find the transversal. Now.
So what line could be a transversal?
This one.
This one?
That
Or
one.
this one?
That one.
Okay. Do we see any alternate interior angles? So we have our parallel lines. We have our transversal. Are there any angles that are opposite sides of those transversals that are inside those parallel lines? So we have,
A and something.
so angle H and angle L, they're inside your parallel lines, opposite sides of your transversal, and so that would make them alternate interior angles. So we could say angle H,
Wait. How did you get
so we have our parallel lines, we have our transversal,
Oh, I was looking at that one and made me think it was like cutting it, so it's like A and that angle.
oh, yeah, so just don't worry about this line at all.
Okay.
Just pretend that one's not there, and then you can see we have alternate interior angles here. Alright, so we have one set of sides we were given, we found vertical angles, and then we found another set of alternate interior angles, so that's 3 pieces of congruent parts. What congruent statement can we say matches these all together? What makes these triangles congruent? Which of those 4 criteria can we use? So we have 2 angles on one side. So once again, we have 2 pairs of angles and 1 pair of sides. And so we know it's going to have 2 A's and 1 S in it. That side, if you look at that triangle, falls in between those 2 angles. So I have my 2 pairs of angles,
Angle, side angle.
so it's going to be angle side. And then we could say triangle Y, congruent to triangle yield. So once again, recognize where that side length falls. If it falls in between your 2 angles, then it's going to be side or angle side angle. But if it falls outside, then it's in between sides. So we do have to recognize that word. Are we okay with this? Going along. Okay, so we're going to start transitioning into actually writing those 2-column proofs and writing the statement and writing the reason. We have an extra property though that we want to talk about before we get there that's going to be helpful and beneficial that might come up. And so what this is called is the reflexive property. So basically when you have a situation where you have 2 triangles, something like this, you can say that AC is congruent to CA. Now, if you were to put this in your own word, why would, or if you had to explain this yourself, why would you explain that that's true? Why is AC congruent to CA? It's the same line. AC and CA are the same line, so obviously it's going to be congruent to itself. It's not going to change distance. So anytime you have 2 triangles that share the same line, I'm talking and writing at the same time. It's not working out. All right. Let's see. It's the same line. Okay. So anytime you have 2 triangles that share the same line, you can automatically say to those 2 that side is congruent with itself. So because both triangles share side AC, you can say AC is congruent to itself, and now there you have one set of congruent sides already without even having to try. And so this doesn't just work for side lengths stuff. It also works for angles. So if you have 2 triangles that somehow share a similar angle or something, for example, you have these 2 triangles, they both share this angle, that's also a reflexive property. This situation won't come up too much, but it will come up later on down the year. So the reasoning behind why those 2 side lengths are congruent is the reflexive property. The statement you would make is AC is congruent to CA. And your reasoning is once again the reflexive property. So we're gonna start walking through some situations where we're actually dealing with those 2-column proofs, just like what we did with those parallel lines, and actually figuring out what are the statements and what are the reasons. But we're gonna walk in slowly, so rather than having you fill out all of that information, we're just gonna start off with some fill in the blanks. So right now, they gave us all the statements, we just need to fill in all the reasons. So we have this situation, we have some given information, we have our proof. The first statement these people made was EF is congruent to GH and EF is parallel to GH. So why were they able to make that as their first statement?
Because they had the same look back between the lines.
Alright, so we can see from the picture, we can tell. Why else do we know that this is true?
Because given.
It's given information. Always remember, just like with parallel lines, the first thing you want to write down is your given information. And then typically when you get your given information, I like to put some little notes along my picture to help me recognize what it is it's talking about. Which sides do I have that are congruent? Which sides do I have that are parallel? Just to help me visualize it a little bit more. So we start off with that. If we notice we have one set of parallel, or we have one set of congruent sides already, so we have one piece of our congruent criteria. We need our other two. The next thing that they say is they said EG is congruent to GE. We have to figure out why is that allowed. Why?
Because they're the same line.
So the EG and GE are once again that same line. They both share it. And so we can say by reflexive property.
That be the reason?
Yep,
Did we
reflexive
say
property.
same line, or do we have to say
I would prefer you to use reflexive property because on that state test, they're most likely going to have drop-down tabs. So like they'll have like a little drop-down tab here. You can click on it. They'll have a bunch of options. Reflexive property is what's going to be in there if you want to use it. And so I would prefer you to use that terminology and use that academic vocabulary. If you want to shorten it to just like RP or something, that's fine. All right. Next statement they gave us was angle 1 is congruent to angle 2, and we have to figure out why.
Because alternate interior angles.
Alternate interior angles again. Once again, we have those two parallel lines. We have our transversal of EG, and that gives us our alternate interior angles. And then they said that this was enough information to say that they had congruent triangles. We need to figure out what criteria they use for this.
I don't know if it's all over the place.
So see what we have. We have a set of congruent sides, another set of congruent sides, and a set of congruent angles.
So, we can use that one.
Well, let's look at how is it positioned. We have a side, an angle in between, and another side. So we can use side angle side. So always we want to look back on the pictures and see how is this information positioned on the triangle, because then it'll allow us to use that. If for whatever reason this angle was over here, and we didn't have an angle in between those two sides, then we wouldn't have been able to do it, and we would say like, cannot be proven congruent, or not enough information, or something like that. But for this situation, we're just trying to prove that they're congruent sides. Are we okay with this, filling in that information? All right, we're going to do one more example. All right, so this one, we're going to have to fill in a couple statements this time, but we still want to say that criteria at the end.
the given, we can go on.
So first thing we want to write down is that given information, good. So we have DC is congruent to BA, and CB is congruent to AD. I'm going to mark that up on my picture. So DC is congruent to BA, and then CB is congruent to AD. So already off the bat, they gave us two congruent sides. So we just have to find one more piece of information, then we'll be done.
That BD is congruent to DB because
Okay. So BD is congruent to DB by the reflexive property. Yep. So they share that side, so once again, it's congruent to itself. Is that enough information to say that these two triangles are congruent?
yes, because the sides because of as
Side, side, side. The only information we have are a bunch of side lines. How it works. Side, side, side.
which is actually easy.
Good. And once again, we're going to practice it throughout the next week until Friday of our assessment. And so we'll add one more thing in on Monday. One more type of criteria that shows up just a little bit. It's less likely than the other ones, but it is a situation we need to talk about. It involves using SSA, but it's like a special situation of when we can use SSA. And there's like one situation when it works, other than that, you can't use it. And so we give it a special name because of that, but we'll talk about that on Monday. But other than that, next week is just going to be a lot of practice. It's being nailing down, making sure we can fill in those information, making sure we can write those congruence proofs, and figure out what is your statement and what are your reasons. And that's the main thing we're going to focus on. Sound okay? What do you mean?
Like, instead of like or
Yeah, so as far as I'm aware, the situations I'll give you are all going to be ones that will be able to prove congruent. So once again, at the beginning, it says prove a situation. And if it's asking you to prove that situation, you need to be able to show that situation. So if for whatever reason it said prove that they're not congruent, then we would have to be able to figure out a way of reasoning on why they're not congruent. But if it's asking you to prove that they're congruent, it is possible. It should be possible. And they shouldn't give you like a trick question. Okay. Perfect.